In this video, we're going to look at finding the LSA and TSA, so our lateral surface area and total surface area of a triangular prism. So notice that this is a second example, and it's a little bit different than the first one if you watched example number 1 for triangular prisms. That one was made up of right triangles. The two bases were right triangles. And we had what I told you we had W and we had L, which I referred to as length and width, which is really the height, right, and the base of the triangle. And I explained why I used different variables for it. Now on this one, notice it's a little bit different because we don't have a right triangle. We actually have an equilateral triangle. Notice that all three sides of the triangle are equal to one another. Notice this side is an 8, this side is an 8, and this bottom side is also an 8. So that is going to change a little bit the way that we approach it, and that's why I made a second video to show you how we could find our answer to this one. First of all, we do want to find our perimeter. The perimeter, it's the same way as the other, but unlike the other where we had to solve for the length of the hypotenuse to find the perimeter, this one they gave us all three values. So I'm going to go ahead and I'm just going to circle them and write them. This first one right here, there's an 8. I'm just going to call that one of the sides. We have another 8. That's another side. And then we have this 8 at the bottom, which I'm going to put that 8 in place of the L and just say that that is the length of the base of my triangle, the bottom of the triangle. Now when it comes to perimeter, we just add up those three sides, right? All three sides of the triangle get added up. So we have 8 plus 8 plus 8. And if we put that in our calculator, we'd have 8 plus 8 is 16, plus another 8 is 24. So our calculator would tell us we added that up. The perimeter is 24. Now, when we talk about the height, we're talking about the height of the prism, right? That's what this H stands for. And we're going to be using those same formulas that you've seen in the last two videos, where for the lateral surface area is going to be the perimeter times the height, and the total surface area is going to be the perimeter times the height plus 2 times the area of the base. Now if I continue on this, my height is just this distance that's between the two bases. And notice I did shade my bases already, right? I knew it was a triangular prism because it had a triangle, and I knew that those triangles had to represent the base. So the distance between these two bases is 12. So my height is going to be 12. And now we can go ahead and we can solve for the lateral surface area. So let's do that real quick, and then we'll come back, get the rest of the information we need, and we'll solve for the total surface area. So I'm going to come down over here, and this time I'm going to shortcut it a little bit since we already calculated the perimeter by adding all three sides of the triangle together, and it was 24. I'm just simply going to write 24 in parentheses for the P, which is my perimeter. And then for the height, I'm going to go ahead and put my height, which was 12, the distance between the two bases. And if I go ahead and put that in my calculator, you see what it gives me. So I have 24, which is my perimeter, times 12, which is my height, and it gives me 288. So let's say that this is centimeters. So what I would write is my LSA, lateral surface area, is equal to 288 centimeters squared. Now we're going to go ahead and we're going to find our TSA. But for TSA, we do have something else we have to find. We have to find the area of the base. And you'll notice that I left this W here out. And that was because I left it blank, because when we had the right triangle, it really represents the height of the triangle. I called it the width because that's what I referred to. But I also said it is the height of the triangle. In other words, from the top of the triangle to the bottom. From the highest point to the lowest point on the triangle. Highest to lowest height. So that's what this is. So this W right here represents the height of our triangle. So I'm going to draw a picture of a triangle. So it's our triangle height. Now, in order to find that, we need to figure out what is the distance between this highest point and the base. And while that may look a little difficult at first, if you don't recognize it, this is basically an equilateral, so all sides are equal. And if we wanted to, we could just cut the triangle in half. Now I drew another triangle, right, another base over here, and because this one was shaded in, to show you what I mean. I'm just going to draw a line from the top all the way down to the middle, and that basically cuts this into 2 right triangles. And then what we can do is we can solve for this leg of the triangle, which we'll call the height. And I'm going to label that the variable W. That's this variable right here. So we're going to find W, the height of this triangle, by using the information that we already have. Now, first of all, we know that all three sides of the triangle are 8. So this side is 8 over here, just like this side is 8. And the bottom is 8 as well. But I want you to recognize that if I drew this line just extending a little further, we have cut the bottom of the triangle in 2 halves. So what I'm going to do is I'm going to take 8 and divide it by 2, and that gives me 4. So that I know that half of this is a 4. And that's important because in order to use the Pythagorean theorem to solve for the height of this triangle, I have to know what this base of the triangle is, which this short leg of the right triangle is, and I need to know the hypotenuse that is opposite the right angle. So I have those two values now, right? Our hypotenuse is 8, one of our legs is 4, and the one we're looking for, which represents our height, we're going to call that W. So I'm going to go ahead and substitute these numbers in to the Pythagorean theorem to find out what the height of this triangle is. So once again, we have our formula, and it's a squared plus b squared is equal to c squared. And I'm just going to label a few things. I'm going to say that W is representative of my A in the formula, 8 is my C value in the formula, and 4 is the B value of that right triangle. So therefore, if I rewrote this, I'd have a squared plus 4 squared is equal to 8 squared. And we'll just continue to work this out. Now, what I'm going to do is I'm going to use inverse operations to get a by itself. So I'm going to subtract 4 squared from both sides. Notice I didn't square the number. I'm just going to cancel it out because I'm going to let the calculator do that work. I'm going to bring down a squared is equal to, and I'm going to do 8 squared minus 4 squared. And I'm going to put that in the calculator. So I have 8 squared minus 4 squared, and it leaves me with 48. So that's going to give me 48. Now we do have to take the square root to get rid of the squaring because we want to know a linear length, right? We don't want to know the area behind something. We want to know how long is this line. So with that linear measurement, we end up with a is equal to the square root of 48. And so that's going to be my W. So my W, the height of this triangle from top to bottom, is going to be square root of 48. And I'm going to leave it as a radical. Now, if you want to, you could go ahead and convert this, but it's going to give you a decimal. And I think it's easier to just leave it as a radical, and we can substitute that radical into our formula when we're trying to find the area of the base. So let's go ahead and do that. We have our W now, right, in our formula to find the area of the base of this triangle, and we have the length, right? That's our L, which is just the bottom side of the triangle, that whole length right there, 8. So I'm going to go ahead and we're going to find the area of the base. So if I were to substitute these values in, I'm actually going to do that right here. So the area of the base, and I'm going to write big B instead of an A. So my big B, area of the base, is equal to 1/2 times L, which is 8, times my width, W, which is the square root of 48. And I'm just going to close parenthesis on there, and we'll see what the calculator tells us. And in this case, I am going to go ahead and write the decimal value, whatever it might be. So let me go ahead. We'll put this in the calculator. Alpha y equals, enter. And I got 1/2 times 8 times the square root of 48. And it gives me this value. So I'm going to write that down. So it gives us 27.71281292. Now this is big B. Alright, I'm going to go ahead and write this value up there on top. So when it says what is the area, I'm just going to round it up here for now. It's 27.71. Now what I will tell you is I typically will use the entire decimal strand inside of the formula, and I won't round it to the final answer if a teacher has asked me to round. That's my personal opinion. You can ask your teacher and see if they want you to do it a different way, but I'm going to go ahead and use this whole number because I want as accurate of a measurement as possible for the total surface area. So I'm going to move this up a little bit, and we're going to go ahead and start filling in what we know. So for instance, I'm going back over here to the perimeter. We know what the perimeter is. We had already used it over here on the left side. It's just simply 24. So I'm going to put that in there, 24. The height, we know what that is. It was 12. That was the distance between the two bases. So times 12 plus 2 times the area of the base, our big B. And here's big B, right? We found it, and it's got this long decimal strand. So I'm going to do 27.71281292. And close parenthesis. And once I put this into the calculator, it's going to tell me the entire surface area of this triangular prism, including the bases, right? So what it would take to cover this entire shape with wrapping paper if it were present, including the 2 bases on the ends. So let's go ahead and get our calculator and type that in real quick. So here I'm going to go ahead and put it in, and we have 24 times 12 plus 2, and then instead of typing in this long decimal strand, I'm going to just click up on the arrow that goes up and highlights it, hit enter, it brings it down and puts it inside of the parenthesis for me, and I'll close it. And now I have the decimal strand in there accurately, and I'm going to hit enter for my final answer. And it gives me 343.425628. So I'm going to go ahead and write that down. So TSA is equal to 343.425, and I'm going to stop there. A lot of your teachers are asking for these to be rounded to the tens place, so I'm just going to underline the tens place, circle the hundreds, and remember, 5 or more raise the score, 4 or less let it rest. So 2 is telling me to let the 4 rest, do not change it. So my final answer is I'm going to put the total surface area is approximately 343.4 centimeters squared. And that's my final answer.